Has the Earth ever truly lost control? If for just one moment in its ancient past, the planet exhaled with such unimaginable force that the very face of the ocean floor was rewritten in fire, long before humans took their first steps, before the continents drifted into the shapes we know, the Earth unleashed one of the most powerful geological events in its history, called a supereruption so vast, so violent, that even today its echoes lie hidden beneath thousands of meters of Pacific water. An eruption not from a single volcano, but from the planet itself. By the way, be sure to subscribe to help this channel erupt. And now, after more than 120 million years, scientists have finally traced the fingerprints of that long-buried fire. A discovery that reveals how an entire underwater world, larger than Alaska, was carved from molten rock. I'm Alex Turner to understand how this happened. We must journey downward far below the waves into darkness, into the deep memory of the Earth itself. Beneath the calm blue surface of the Western Pacific lies a world few people know exists, an underwater giant, silent and unmoving, yet shaped by unimaginable violence, the Ontong Java Plateau. To most of us, it's nothing more than a name on a map. But to geologists, it has always been a mystery, a puzzle so massive it defies ordinary explanations. Imagine descending into the deep ocean. Sunlight fades, temperatures drop, the water becomes ink black and heavy, and then, rising from the abyss like a submerged continent, you find it a slab of volcanic rock so vast it covers more than 1% of Earth's entire surface, thicker than Everest height, stretching wider than Alaska, a continent of frozen lava. But here's the strange part. In geological terms, this gigantic plateau appears almost overnight. No slow buildup, no long volcanic chain leading to its creation. It simply arrives in the geological record, fully formed, as if the planet had poured out its molten heart in one sudden breath. For decades, scientists were left asking the same question. Where did all this lava come from? Recently, researchers from the University of Maryland and the University of Hawaii uncovered a hidden clue, a faint but unmistakable trail of volcanic structures leading back across the Pacific, the kind of pattern only created by a hotspot, a deep mantle plume rising from thousands of kilometers within the Earth. This is the same kind of engine that powers Hawaii's volcanoes today. But as scientists traced its path, they realized something unsettling. This wasn't just a hotspot. This wasn't just another volcanic plume. This was something far greater. A plume capable of generating one of the largest volcanic events in Earth's history. The clues were in place. Now it was time to uncover the eruption that created them. Around 120 million years ago, the Pacific Ocean looked very different. No familiar islands, no ring of fire, just a vast, deep basin. And beneath it, pressure building in absolute silence. Deep in the mantle, nearly 3,000 kilometers below, is a rising plume of superheated rock, which are gathered for millions of years. It rose slowly, widening, concentrating heat, swelling like a submerged thundercloud. And then, it reached the lithosphere. What happened next was not an eruption as we know it. It was a supereruption. In an instant measured not in seconds, but in geological heartbeats, the crust cracked open across thousands of kilometers. Lava didn't just flow, it flooded. Not from one volcano, not from a chain of volcanoes, but from thousands of vents erupting across the ocean basin simultaneously. Trillions upon trillions of tons of molten basalt surged upward, forming what geologists call a large igneous province, or LIP, which is a colossal outpouring of fire that reshapes the planet's crust. The ocean above it boiled. mountains of magma rose, cooled, and stacked upon each other like layers of black glass. For nearly 1 million years, the eruption pulsed, expanding outward, building the massive plateau we now call Ontong Java. When it finally ended, the world was not the same. The gases released were carbon dioxide, sulfur, and methane, which drifted into the atmosphere, warming some regions while cooling others. Ocean chemistry shifted dramatically. Some species vanished, others struggled to adapt. It wasn't a mass extinction, but it was a close call. And yet, in the timescale of Earth's 4.5 billion year history, this event, this unimaginable outburst, was simply a single beat of the planet's fiery heart. But the story doesn't end here. Because this eruption left a trail, a chemical and geological fingerprint stretching across the Pacific. And scientists are only now learning to read it. For decades, scientists stared at the Ontong Java Plateau and saw only an isolated anomaly, a singular, mysterious outpouring of volcanic rock. But deep beneath the South Pacific, another structure waited to be understood. A chain of underwater volcanoes stretching like a constellation etched into the seafloor. At first glance, these two features seemed unrelated. One was an enormous volcanic tableland, the other a line of extinct seamounts lost in the abyss. But geology, like history, rewards those who look for patterns. Researchers began comparing rock samples from both regions, fragments retrieved from drilling missions, dredging expeditions, and deep-sea submersibles. What they found was astonishing. Each piece of volcanic rock carried a chemical signature, a fingerprint. Ratios of isotopes, strontium, neodymium, and lead matched almost perfectly between the Ontong Java Plateau and this distant volcanic chain. Rocks separated by thousands of kilometers shared the same molten ancestry. Slowly, a picture emerged, using isotopic dating to determine age, using mantle tomography to map structures kilometers beneath the crust, and plate reconstruction models to retrace the Earth's shifting surface. Scientists finally connected the dots. The seamount chain and the Ontong Java Plateau were born from the same plume, the same monumental surge of magma that tore through the Pacific lithosphere 120 million years ago. Two geological features, separated by time, separated by distance, yet bound by the same fiery origin. It was like discovering that two distant brushstrokes on opposite sides of a canvas were painted by the same hand as one continuous motion, frozen across millions of years. What once seemed random now belonged to a grander, deeper pattern written in the earth itself. But if the eruption was the brushstroke, what was the hand that painted it? To answer that, we must journey even deeper into the beating heart of the planet. Far below the crust we stand on, beyond the shifting plates and the flowing asthenosphere, lies a region we rarely think about called the deep mantle, a place where temperatures rival the surface of the sun, and rock behaves like a slow, luminous ocean. This is where mantle plumes begin. Imagine 3,000 kilometers beneath your feet, a pocket of superheated rock slowly rising, pushed upward by heat escaping from the Earth's core. It moves not in years or centuries, but in millions of years, creeping upward, like a glowing titan emerging from an ancient dream. When such a plume reaches the rigid crust, it doesn't politely erupt through a single vent. It bulldozes its way in. It overwhelms the lithosphere. It creates events so massive they redraw coastlines, alter climates, and build entire provinces of new crust. These plumes are the engines behind hotspots in Hawaii, Iceland, Yellowstone. But when one becomes unusually large, unusually hot, or unusually focused, it can trigger the kind of super eruption that created the Ontong Java Plateau. Understanding these plumes isn't just academic curiosity. They're responsible for the breakup of continents, the birth of new ocean basins, and changes in global temperature. The study connecting the South Pacific hotspot trail to the Ontong Java Plateau does more than explain an ancient eruption. It refines our understanding of how the mantle itself behaves. Because 120 million years ago, during the early Cretaceous, the Earth was rearranging itself. Continents drifting apart, oceans opening, climate transforming. And through all of this, the plume beneath the Pacific kept rising, pulsing, feeding fire into the crust above. Beneath the calm surface of today's Earth, beneath our cities, oceans and mountains, this process continues slow, deliberate and unstoppable, a whole creation in slow motion. The story of the Ontong Java eruption is not only one of creation, it's also one of consequence, because when the Earth breathes fire on a planetary scale, the world above must adapt. As trillions of tons of magma rose from the mantle, they brought with them enormous amounts of gases like carbon dioxide, sulfur dioxide, methane. These gases seeped into the ocean, drifted into the atmosphere, and began to tip the delicate balance of Earth's climate volcanic. CO2 warmed the planet. Sulfur aerosols cooled certain regions. Acidification altered the chemistry of oceans that teemed with life. The result wasn't a mass extinction, but it was a profound disruption. Scientists studying the fossil record from this time see clear evidence of ecological stress. Oxygen-depleted waters spreading like silent deserts, reef systems collapsing, species diversity dropping sharply before slowly recovering. It was a moment when life was tested. A reminder that the same forces that build the Earth's crust can also challenge everything living upon it. And yet, life endures. Ecosystems reorganize. New species evolve. Old ones adapt. From destruction came renewal, proof that even in chaos, the planet rebuilds itself. To piece together this ancient story, scientists had to become detectives, not of crime, but of deep time. They drilled into the seafloor, pulling up cores of black basalt older than entire mountain ranges. They examined isotopes under microscopes, each ratio telling a chapter of the eruption's past. They used seismic waves like medical imaging for the planet to map the plume's ancient pathways. Geochemists, volcanologists, tectonic modelers of each discipline added a clue. Piece by piece, decade by decade, the mystery of the Ontong Java Plateau began to take shape, and with every discovery, the story grew richer. Because this wasn't just about rocks, it was about understanding the forces that forged our world, forces still active deep beneath our feet. With every data point, every reconstructed map, every ancient lava flow deciphered, we are reading the Earth's autobiography, written in stone and time. We are, in a sense, detectives of the impossible, tracing the whispers of a fire that burned 120 million years ago. Today, the Ontong Java Plateau lies still and quiet beneath the Pacific waves, but the story it tells is anything but calm. It is a reminder that our planet is not a static world. It grows, it shifts, it breathes. Beneath continents and oceans, heat rises, mantle plumes churn, tectonic plates drift like restless rafts on a sea of stone. The same processes that shaped the Earth's ancient past still whisper beneath us today while forging new crust, opening new oceans, setting the stage for the world that will exist millions of years from now. Our planet was born in fire, and that fire still burns within. Every eruption, every tremor, every ripple in the crust is a gentle reminder that the Earth is not done creating. And neither is our curiosity. If you enjoyed this journey into Earth's hidden past, if these stories of fire, ocean, and deep time spark your imagination, Make sure to like this video, share it with someone who loves science and wonder, and subscribe for more journeys into our incredible planet. And don't forget to turn on the notification bell, so you never miss the next adventure. The Earth has many more secrets to tell. Let's discover them together.